This is a slug, and this is also a slug. The only difference is one lives on land and one lives in the ocean. On land, the scariest thing a slug can do is eat your tomatoes. They move at 0.03 miles per hour. Their only defense is slime. They dry out if the sun comes out too long. And if you pour salt on one, it dissolves. That is the full biography of a land slug. It is the animal equivalent of a soggy newspaper. But in the ocean, slugs steal venom from jellyfish. They develop immunity to toxins that kill humans. Some of them photosynthesize like plants. And one species hunts the Portuguese man-o-war and wins. The ocean took the world's most harmless animal and turned it into a chemical weapons system. Sea slugs and land slugs are both gastropod mollusks. Cousins to the common snail, just without a shell. Same evolutionary family, completely different outcome. The question is why? And the answer involves buoyancy physics, chemical warfare, and one of the most remarkable cases of biological weapon theft ever documented. To understand what the ocean did to the slug, start here. This is Glaucus atlanticus. Scientists call it the blue glaucus. Most people who find one washed up on a beach call it the most beautiful thing they've ever seen, and then immediately touch it. That is a mistake. The blue glaucus is roughly 1.25 inches long. It is electric blue on top, silver on the bottom. 6 clusters of finger-like projections fan out from its body like small wings. It floats on the surface of the open ocean, and it floats upside down, not because it's dead, by design. The blue glaucus hunts the man-o-war deliberately. Here's the mechanism. The slug traps a bubble of air inside its stomach. That bubble acts as a biological flotation device, keeping it suspended just below the ocean's surface film, upside down, riding ocean currents. It can't steer with any real power. It simply drifts until it finds something. That something is usually the man-o-war. When the slug reaches one, it clamps on and begins eating, starting with the tentacles. The nematocysts don't fire. Every other animal in the ocean would get stung immediately. The blue glaucus is immune to them. But it doesn't just eat them, it keeps them. As the nematocysts travel through the blue glaucus's digestive system, instead of being broken down, they are carefully routed to specialized storage sacs, called cnidosacs, located at the very tips of those finger-like serrata. The stingers arrive, intact, loaded, pointing outward. The result? A slug that has harvested the stinging cells from an entire man-o-war, concentrated them in a small body, and is now more venomous than the animal it just ate. It didn't evolve a venom gland. It didn't develop its own toxin. It just took one from the most dangerous thing it could find and kept it. If you find one of these washed up on a beach, and they wash up in large numbers along certain coastlines, sometimes by the thousands, do not pick it up. This has happened repeatedly. People find them, mistake them for alien jewelry, and make contact. A dead blue glaucus can still fire its nematocysts. Multiple documented hospital visits. Some reports describe it as worse than a direct man-o-war sting because the nematocysts are more concentrated. For comparison, the most dangerous thing the garden slug ever does to a human is that a dog might eat one and contract a lungworm infection from it. Slightly different threat profile. But the blue glaucus is just the first strategy. The ocean didn't make one terrifying slug. It made hundreds of species, each with a completely different answer to the same problem. And some of those answers shouldn't be biologically possible. The land slug didn't fail to evolve weapons. It never needed to. Its job, its entire ecological function, is decomposition. It eats decaying plant matter, fungi, rotting fruit. The competition for dead leaves is not fierce. Nothing is racing a slug to a piece of compost. The threats are real. Birds, hedgehogs, ground beetles, but they're solved the same way they've always been. Be small, be slimy, and produce enough offspring that some of them survive. Land slugs have been running that same strategy for 50 million years. It works. You don't improve a strategy that works. Now look at the coral reef. The reef is not peaceful. It is one of the most contested ecosystems on the planet. Every surface competed for, every calorie defended. The sponges are chemically toxic. The corals fire nematocysts. The anemones are armed. The flatworms are poisonous. The fish have spines, venoms, and teeth. To exist on a reef as a soft, slow, defenseless animal is to offer yourself as food. Evolution doesn't allow that for long. You either develop a weapon, become inedible, or disappear from the fossil record. Land slugs never faced that pressure, so they're still what they were before the dinosaurs went extinct, soft tubes that eat rotting things and die from salt. Sea slugs got dropped into the most chemically armed environment on Earth and had exactly one option: adapt. There's a physics reason this divergence is as extreme as it is, and it explains everything. On land, gravity is relentless. It pins every soft-bodied animal against the ground. If a garden slug tried to grow to the size of some Nudibranchs, the Spanish dancer, which can reach 20 inches, it would collapse under its own weight. The foot that it uses to move would fail. Its organs would compress. Gravity doesn't negotiate with soft bodies that try to get big. In water, buoyancy cancels gravity. The slug's weight is supported on all sides by the water column itself, which means its body can grow larger, develop more complex structures, and navigate 3 dimensions. The blue glaucus floats. The Spanish dancer swims, undulating its full body in ribbons through open water. A land slug's most ambitious movement is crossing a garden path. This is not a mild difference in environment. It's a completely different set of physical rules, and it produces a completely different range of possible animals. Brute venomosity isn't the only trick. Meet the Aeolid nudibranchs, not one species, but an entire family, hundreds of them, all sharing one behavior that makes no sense the first time you hear it. Aeolids eat sea anemones, hydroids, jellyfish, all of them covered in those same spring-loaded nematocysts, the stinging cells that the man-o'-war uses to hospitalize people. Against every other animal, these fire immediately on contact. Against Aeolid nudibranchs, they don't. But it doesn't stop at immunity. The Aeolids process the stinging cells through their digestive tract without breaking them down, then route them, intact, loaded, undetonated, to specialized sacs at the tips of their serrata, the same finger-like projections the blue glaucus uses, packed with stolen ammunition. If a predator bites an Aeolid, the serrata don't just sting, they can detach entirely, release the stingers directly into the predator's mouth, and the nudibranch crawls away. The severed serrata grow back within days. It's not just a defense, it's an ambush. The slug is baiting something into biting it. Some species made this system even more deliberate. Flabellina affinis doesn't eat every available cnidarian. It specifically targets hydroids from the genus Eudendrium, not because that's the only option available, but because that particular species produces a nematocyst with higher discharge velocity. The nudibranch is choosing its ammunition based on quality. The garden slug, meanwhile, is unarmed. It produces mucus that tastes bad to hedgehogs. The ocean's version is selecting weaponry with the discernment of an armorer. Stealing weapons from your prey is remarkable, but the next strategy doesn't steal anything. It manufactures, and what it manufactures can kill an entire aquarium. The Phyllidiidae family of nudibranchs don't look like weapons. They look like poorly decorated luggage. Lumpy, ridged, black and white with yellow accents. They move slowly, they don't bite, but they eat sponges. And sponges are chemically some of the most toxic organisms on the reef. Sponges have no armor, no speed, no claws. Their entire survival strategy is biochemistry. They produce sesquiterpene compounds, isocyanide derivatives, and alkaloids so potent that a single exposure causes immediate chemical burns in most predatory fish. Marine biologists call sponge chemistry a toxic minefield. Fish learn not to eat them, sometimes after one attempt. Phyllidiid nudibranchs eat the sponges, and instead of destroying those chemical compounds through digestion, they absorb them. The toxins are sequestered into the nudibranch's mantle, the tissue lining its outer body, and secreted outward through the skin. The entire surface of the animal is now a toxic field. If a fish swallows one, and some fish make this mistake, the fish often dies. Not from a bite, not from a sting. The slug doesn't fight. The slug is the poison. In laboratory settings, researchers have placed Phyllidiid nudibranchs in closed tanks and documented the water chemistry changing, within hours, to lethal levels for every other organism in the water. The slugs weren't stressed, they weren't attacked, they were just existing, and the passive presence of their skin chemistry was enough to make the water fatal. A land slug in a tank of water would be absorbed by the water. A sea slug in a tank of water turns the water into the weapon. Weapon theft, chemical manufacturing. Both are impressive. But the next one didn't bother with weapons at all. It stopped being an animal. This is Elysia Chlorotica. It's a sea slug. It's also a plant. Both of those statements are true at the same time, and this should not be possible. Elysia Chlorotica feeds on a specific green alga called Vaucheria litorea. When most animals eat algae, they break down every component, including the chloroplasts. Chloroplasts are the cellular machinery that performs photosynthesis. They're what makes plants green. They capture sunlight and convert it into chemical energy. Every other animal that consumes algae destroys them. Elysia Chlorotica doesn't. The slug eats the algae and extracts the chloroplasts intact. Instead of digesting them, it incorporates them directly into the cells lining its own digestive gland, where they remain functional, still capturing light, still performing photosynthesis inside the body of an animal. The slug turns a deep, vivid green, not from pigmentation, from active, working photosynthesis happening inside its own cells. After a few weeks of feeding, Elysia Chlorotica can survive for months on sunlight alone. You take one, put it in the light, give it no food, and it lives, because it is its own food source. No other animal does this on its own. Corals house photosynthetic algae inside their tissue, but those are partnerships. The algae are separate organisms living inside the coral. Elysia Chlorotica takes the chloroplasts themselves, the machinery. They are no longer algae, they are part of the slug. The land slug's most sophisticated biological trick is producing mucus with mild antibiotic properties that prevents infection in its own slime trail. That is the gap we are measuring. The last one didn't steal weapons, it didn't manufacture toxins, it didn't solve the problem of food entirely, it just got large, extremely large. And then it learned to dance. Most sea slugs are small. The blue glaucus is 1.25 inches. Elysia Chlorotica is barely 2 inches. The ocean also produced a version that is none of those things. Hexabranchus sanguineus, the Spanish dancer. It can reach 20 inches long, longer than your forearm, and it is the deep scarlet red of something that should not exist. When it is threatened, it does not hide. It launches itself off the reef and swims. Full-body, ribbon-like undulation through open water. Waves traveling down its body like a flag in wind, which is where the name comes from. A slow-motion explosion of red moving through blue water. It absorbs sponge toxins the same way Phyllidiidae does, feeding on sponges of the genus Helicondria and retaining their chemical compounds throughout its body. It is simultaneously the most visually striking and the most chemically defended large nudibranch in the ocean. And when it lays its eggs, it deposits them in coiled rose-shaped masses on the reef, which are also chemically armed with deterrents from the same sponge toxins. The garden slug lays eggs in a pile of soil and moves on. The ocean slug lays a chemical rose and dances away. Fortunately, we live on land. The slug eating your garden is not going to steal nematocysts from a jellyfish. It is not going to secrete sponge toxins through its skin. It is not going to photosynthesize for 3 months on a windowsill. It is going to eat your basil and dry out by noon. But in the Pacific right now, and the Indian Ocean and the Atlantic, there are hundreds of species of sea slugs doing all of the above. They started from the same animal your garden pest came from. The ocean just never let them stay harmless. It put them in an environment that demanded a weapon, and the weapons it got back were stranger than anything evolution produced on land. Weapon theft, toxin manufacturing, photosynthesis, a 20-inch predator that dances through open water and defends its eggs with chemistry. The ocean did all of that, with a slug. If you want to see what else the ocean turned into something unrecognizable, our video on sea spiders is exactly what it sounds like, and it's worse. And if you haven't subscribed, now is a good time. New video every week. We're not done going deeper.